Hello everyone, this session is a show and tell on the Analyse bus open data service. So we'll quickly run through a small slide deck covering the user setup and the matching logic, and then we'll jump into a live demo of the site to run through each of the pages, how to use them, and any small iterations. So in terms of user management, the old ABODS logins, so as of a week ago when recording this video, so the 25th of February, will no longer be valid. User management will now be controlled via the bus open data service. So when you receive an invite, it will be from the bus open data service, but then when you set up those credentials, you will then be able to use those credentials on the Analyse bus open data service to log in. So the most significant changes made are backend changes, so the database, the underlying data, and the matching logic. However, the link to access the site has remained the same, and there's some minor changes to the user interface, so the look and feel of the website has remained the same. Please ask your organization admin if you require any additional users in the future. For operators, you will already have your organization admin assigned, but for local transport authorities, we have been assigning users as standard users, and we'll be reaching out in the near future to set up any organization admins who can then request access to additional users. If you are unsure on your account type or have any questions, please email the BODS help desk. So that's bodshelpdesk@kpmg.co.uk. So in terms of the matching logic, there's a couple of fundamentals to go through first. So there is the trans exchange files, which are uploaded to BODS with the schedules data. So what are the buses doing in terms of their timetables? That's imported to ABODS on a nightly basis. So at around 7-8 o'clock tonight, we'll take a copy of the BODS database, assess which journeys are running tomorrow, and create a large table with all of the journeys that we're expected to run tomorrow. We then have the serial VM data. So this provides the GPS locations of the buses live every 30 seconds. And that's received from the ticketing machines. And for us to match these two pieces of information, or these two data sets together, we need three important data points to match, and that's the national operator code, the line, and the journey code. If those aren't aligned, then we won't be able to complete matching, and you will see an incomplete score on the front end on the OTP stats. So in terms of the actual logic, we have the departure detection logic, which is a position within 70 meters of a stop. So once we have a live location within 70 meters of one of the scheduled stops, we wait until we see two successive GPS positions that are recorded outside the stationary zone of these positions. So this is to ensure that we are recording a departure and that the bus is moving away from that stop. We have a reset condition, so if the bus comes back inside the stationary zone, then we have a reset and we'll wait for another position within 70 meters. This is to handle GPS jumping, so where a bus is actually stationary, but the GPS locations are moving around. Then we have two slightly different behaviors. So we have the start of a journey. At the start of a journey, we wait 5 minutes to confirm there's no reset condition met. So that, as I mentioned, that's to do with the GPS jumping, or to do with when a bus travels near the stop and then comes into the bus depot and actually comes to the stop. Then we have the mid-journey stops, where we have do not rematch if the stop has already been matched in the correct sequence. So we rely on the stops being matched in a sequential order. That doesn't necessarily mean, 1, 2, 3, 4, 5, but the value has to increase of the stop index. So it could match 1, 2, 5, 6, 7 in terms of stop indexes, but it wouldn't match backwards. So it wouldn't match 5, 4, 3, for example. And then once we're happy that all of those conditions have been met, we record that departure time, and that is what you will see surfaced on the front end or on your on-time performance statistics. We then have this estimated additional blocks. So this is a new feature that's been added for areas of 3G outage where we won't receive as many GPS locations. This does not necessarily need a position within 70 meters of the stop. So we see when two successive GPS positions intersect the 70-meter radius, we estimate the departure time. So this is relying on two GPS locations that cut across a stop. We can then assume that the bus has visited that stop, and we can estimate departure time. There's a toggle on the top right of the front end which will separate these statistics if you want to use this estimated or not. And then finally, we have the arrival detection logic. So at the end of journey, so for the final stop, we are waiting for a position to be detected within the zone, and we record the first position captured within that stationary zone. The last stop can only be marked as on time or late, so the last stop will not be marked as early, and that's because from a passenger's perspective, the passenger will be happy to arrive to the last stop early. So that's a quick overview of the logic. And now we can jump into the site. So the first page that you will come to is the dashboard. And the dashboard is a summary of your statistics. So it compiles data from the various pages around ABODS. You've got your on-time performance summary here on the left-hand side and your feed monitoring statistics on the right. So in terms of on-time performance, we can select a specific national operator code within the organization that you're assigned to. We've got our on-time statistics. So for all of this organization, we've got 80% on time, 17% late, 2% early. Our top 3 and bottom 3 performing services. So the RG2 over the last 7 days was 99% on time, and that's a 4% or 3.87% increase from the week before. So that's comparing the last 7 days to the 18th to the 25th of February. The vehicle count is a count of how many vehicles can we currently see on the Siri VM data. So from the live location data, how many individual vehicles are running, and the expected looks at that timetable data. So how many vehicles are actually scheduled to run. I will go into a bit more detail in terms of the actual logic when we go into the feed monitoring. And then finally, we've got the feed status. So this summarizes the active and inactive feeds from the feed monitoring page. You would usually see your inactive feeds come up on this page first. However, this organization doesn't have any inactive feeds. And then this toggle at the top, we've got timing points. So these are points where buses will usually aim to be on time, and the stops in between or around those timing points. So you can toggle between just specifically the timing points or all of the stops, including the timing points. You can navigate to feed monitoring using these links here or on-time performance on the bottom. So if we jump to the feed, I can search for a specific organization, and this data shows me, so I've got an active feed here. So active feeds will come up with a green tick, inactive will be a red cross, and that is calculated on an hourly basis. So we will assess for the previous hour, were we expecting a bus to be running based on the timetable data? If yes, did we receive any live location data for that hour? If we did, it'll be shown as an active feed. If there's no live location data for an extended period of time, it will be classed as inactive. So essentially we check, is their buses supposed to be running from this national operator code? And is there actually live location data from that national operator code? Then we have feed availability. So on a minute-by-minute basis, over the last 24 hours, this will assess whether there was a feed available or not, whether there was a feed being received by BODS. As an example, if we were expecting data for 24 hours and we only received data for 23 hours, the availability would be 96%. This feed availability is 100%, so that's saying that we were expecting data across the last 24 hours, and when we were expecting data, we received data throughout that whole time period. Update frequency goes into detail in terms of how frequently did we receive GPS locations for the different vehicles that's for this national operator code. So for each of the vehicles, we were expecting a GPS location every 20 seconds. Last outage is when was the feed last inactive. So this feed was inactive 1 day ago. If I would have logged in 24 hours ago and looked at this page, I would have seen this feed with a red cross. And here is a graph of the feeds over the last 24 hours. So you can see 24 hours ago, we had a high volume of vehicles active. It dropped off over midnight, as you'd expect, and then picked up again until now. So you can click into a specific national operator code. You can navigate between the different national operator codes up here. And this is a live status of your feed. So currently there are 26 vehicles in the serial VM data or the live location data, and there are 26 vehicles in the timetable data. So that's saying that we expect 26 vehicles, and we can actually see 26 vehicles driving around the roads currently. And then update frequency, which is the same behavior as the summary page. You can then look into a more granular breakdown. So over the last 24 hours, what we're expecting to happen on an hour by hour basis. So from 12 o'clock till 1 o'clock, we're expecting 60 vehicles, but we only saw 59 in the live location data. So that suggests that the live location data or the timetable data needs updating for one of those services. The last 20 minutes will give you a breakdown on a minute-by-minute basis, but this feed doesn't look like it's been active for the last 20 minutes, so we don't see any data there. Then we can go into view feed history, where here we've got a breakdown of each day until the 4th of December. You can navigate the days by clicking the bar at the top, or you can click day by day using the previous and the next. Feed availability and the average update frequency are the same behavior, but here we can see a more granular breakdown across the 24 hours. So every 10 minutes, what were the expected vehicle journeys and what were the actual vehicle journeys that we received. So now to jump into on-time performance. So on-time performance is the core page for your on-time statistics. You can filter across a custom date range here, so you can choose potentially a month or 2 specific days, or you can choose the preset timeframes in this toggle. What this is showing us is from the 26th to the 20th of February, we recorded 575,000 departures. 78% of those were on time, 2% were early, 19% were late, and 14% were incomplete. If you toggle over the incomplete, you can see a breakdown of why were these matches not completed. So 20,000 stops with missing service from real-time data, 17,000 with missing journey code, and the remaining 2 are to do with live location. But to quickly go over the first 2, so 20,000 stops with missing service from real-time data. As I mentioned earlier, we require 3 things to align between the timetable and the live location data. That's national operator code, line or service, and journey code. So 20,000 stops, we could match the national operator code. So we saw that there was the national operator code in the live location data, but we couldn't find the service. 17,000 stops with missing journey code. So we could find the national operator code, we could find the service, but the journey code didn't match up. There was a misalignment in that journey code. And then the remaining 2 are to do with the live location data. So 40,000 with missing real-time data in the zone of a stop. So we matched the journey code, we matched the knock, the service and the journey code, but we couldn't see a live location within the radius of a stop. And finally, 15,000 stops with a GPS location in the zone of a stop. So we saw a GPS location in the zone, but we couldn't match it for some reason. Quite likely that we saw the GPS location going in the wrong direction, therefore we didn't match it. You can search for a specific operator here, and you can break down your stats. So if we filter, we can filter for the best performing and the less well performing, and a graph over that time period. So because I've chosen across 3 days here, it will break it down per hour. So these dots are per hour, but if you choose over a longer time frame, it will probably break it down per day. So what's your on-time percentage across that time frame as a graph? Then we have these toggles at the top. So compare thresholds. This goes into detail or gives you an additional filter to change the threshold that we define as on time. So the default values are if the bus is greater than 1 minute early, it'll be classed as early, or 1 minute before the expected time, it'll be classed as early. And a value greater than or equal to 6 minutes after the scheduled departure time, the bus will be late. So if I compare these statistics, I'd expect the values to be the same, which they are. If I change these statistics, it is changing my definition of on time. So now I would be expecting anything between 10 minutes early and 10 minutes, or 10 minutes before the scheduled and 10 minutes after the scheduled will be defined as on time. And what that naturally means is you will expect a larger percentage of on time when you increase that threshold. So here we can see around 90% of the services were within 10 minutes early and 10 minutes after the scheduled departure time. We can also refine results. So when you filter over a specific time frame, so if you look over a month, you can filter for a specific day in that month. So I could choose a time frame over the last 28 days and only filter for the Mondays in that 28 days. I could also filter for a specific time, so from 12 o'clock until midnight. Or I can filter out specific OTP scores. So if I choose 10 minutes as my maximum early, 10 minutes as my maximum late, that will remove any on-time scores or any on-time scores where I have a time difference which is more than 10 minutes early or more than 10 minutes late. I then have these toggles, and the timing points and the all stops works. This is exactly the same as in the feed monitoring, where we can filter specifically for timing points or all of the stops across the services. And then we have the estimated and the evidence-based. So the estimated, as I mentioned earlier, tries to fill in the gaps when we have some missing live location data. So you would expect naturally the incomplete stat decreases slightly. So it goes from 13.86 to 13.4. So a very small decrease. That suggests that this operator has a good coverage of 3G across their services. Whereas with other operators, I'd expect that incomplete data to decrease significantly. And I'll jump into a specific vehicle journey to show how that works on a journey level. But finally on this page, we've got the admin areas. So I can filter for a specific admin area, or I can select one on the map. So if I chose Greater London, for example, it will show me all of the services that travel through Greater London. Important to note that if I chose a service if I chose Greater London as my admin area, it would bring me all the journeys that travel through Greater London. So if a journey started in Essex and travelled to Greater London, it would bring that journey into both the stats for Greater London and Essex. So it's done at a journey level. It wouldn't separate those stops and put them half and half in Essex and half in Greater London. So then if I select a specific operator, I will choose Unilink. I've got very similar statistics, but on a national operator code level. I will filter for over the last 7 days. So for Unilink, I can see I've got an on-time percentage of 93% on time, 4% late, 1% early, and 13% incomplete with that breakdown as well. I can search for a specific service, or I can filter for a specific percentage of on time or late or early, etc. But if I can filter here as well for a count. So I can choose a percentage or a count, or I can choose to hide a specific column. So if I don't want to assess the on time, I can hide that column so it's clearer to see. And then we have the graphs up here. So these are really useful for investigating where your services are performing well or less well. So I can look at the timeline. I can assess over a week what were my on-time stats over each of those days. So on the 25th, I was 92% on time, 93% on the 26th, and so on. So I may want to investigate February the 28th because my on time slightly drops there to 92%. Then what I can do is select specifically the 28th, and I can see the performance across the day. So I know that around 3 o'clock, 4 o'clock, the on time decreases and the lates start to increase. And then I can jump into my specific vehicle journeys to see what was happening around that time. But just to jump into these quickly, so distribution, we can see a breakdown of what intervals my bus was in. So 701 of my stops were within 0 minute of the expected departure time, 381 within 1 minute, and so on. Time of day is more useful. Oh, no, time of day we can assess on an hour-by-hour breakdown what were the on-time scores. So again, we know that around 2 till 4 o'clock we have a larger percentage of late and less on time. And we can assess day of week, which is more useful over a longer time frame. So will help you identify whether a specific day is causing on-time issues. Here we can see on a Monday and a Sunday, the on-time is improved compared to the Tuesday to Saturday. So then we can jump into a specific service. So here it's very similar statistics, but for a specific service, the additional tab being a map. So the map breaks down the routes that are traveled by this service. So it looks like there's one route traveled by the service. And you can see at each of these stops, how well did they perform. So each of these is green, which suggests that over 80% of the stops that were recorded there are on time, but you would see an orange if it was 60 to 80% of them were on time, or red if less than 60% of them were on time. So I'll now jump into your vehicle journeys. So as I said, you can use your on-time performance to investigate a specific time where your services might not be as on time. And then you can jump into your vehicle journeys. So you can filter for a specific day, specific national operator code. I'll carry on with Unilink, and a specific service because we were looking at the U7. I'll look at that. And say you were wanting to look at around 7 o'clock because your services were not as on time, you can click into your start time and it will bring up that journey. So here we've got a specific journey code or a specific start time. So the 7:30 for the U7. We can see the scheduled stops. So we know that the bus, based on the timetable data, was going from Centenary Building to St. Thomas Church from 7:30 to 8:06. And then we've got the actual times on this right-hand side. So it looks like this bus was pretty much on time. You can see more granular detail. If you click on all stops, it will show you the seconds. And then you can zoom into the map to see on a more granular detail what actually happened to this bus. So the stops based on the scheduled data will be with the circular icons. So that's our first stop. And then if you zoom in at a finer level, you can see these dots. So these dots are the live locations of what the bus actually was doing. So at 7:30:21, we know that the bus had just departed from that stop. And then the next location we receive is at 7:30:52. So around 30 seconds later, 31 seconds later. So this can help you investigate what's happening on a specific journey level and might help you identify any changes in your timetable data. I'll just give a quick example of the estimated matching. So here's an example where we've got a service that was running mainly on time, but we can see that the pink is highlighting that it was running early at specific points. but we have some incomplete stats in here. So if I go to all stops, I've got 14.2% of my data was incomplete. But if I toggle to estimated, it fills in some of those gaps. So then I have 0% incomplete data. If I zoom into one of those specifically, so we can see at Plantation Road, we've got a location at 11:01:32 up here, and a location at 11:01:53 up here. So it looks like these were every 30 seconds, but the bus was moving quickly and it didn't stop at that specific stop. So, but it does look like it passed that stop. Therefore, we fill in and estimate that stop based on it traversing that stop. That's an insight into vehicle journeys. And finally, we've got corridors. So corridors allow you to set up a specific set of stops across a road. So to create a new corridor, you can click create new corridor. You can name it a memorable name. So I'll just call this test. You can search for a specific location. So you can either zoom into a specific stop or location, or you can use the search bar for a postcode or a NAPTAN stop point if you filter this filter up here. And then you can zoom in, select a stop, and that will search through all of the timetable data and find sequential stops based on routes. So I know that from North Road East, all of these stops are travelled through from that stop based on a journey. So then I can start building my corridor where it will keep suggesting stops that are in that corridor. So we know that there is a bus route that runs from North Road East to Railway, to Pennycombe Quick and Stewart Road. Then I can finish creating my corridor, and once I finish creating my corridor, I'll just click on one that was pre-made. I'll be shown something similar to this. So for this corridor, it's Coast Road, Devonshire Gardens, all the way to Haymarket, St Mary's Place. And I've got my date range up here. So again, I can select a specific date range or a preset range. I can toggle between estimated and evidence, which helps fill in some of the data. Or I can edit my corridor. So I can see when toggling to estimated, it doesn't reduce the missing transits. Again, that shows that this data quality is good in terms of the frequency of the pings received. But these summary stats show that we have 677 recorded transits, 378 are missing. So that'll be due to those incomplete reasonings, maybe a misalignment between the national operator code or the journey code. Across from the first stop to the last stop, the average journey time is 13 minutes and 36 seconds, which equates to a 40 mph average speed. And that's across 4 separate services. And you can see a breakdown of those 4 separate services at the bottom of the screen. So across this corridor, we know that 306, 307, 308, and 309 travel this route. You can see a breakdown of their average journey times, all relatively similar average speeds, and the scheduled transits. You can also see a breakdown of, in a similar fashion to on-time performance, the timeline. So what was the mean, minimum, maximum journey times on each of these dates? So on February 25th, the mean was 14 minutes 16, and then 26th was 13 minutes 45, and so on. For time of day, we can see a breakdown on each hourly interval. So from 5 o'clock to 6 o'clock, the mean was 10 minutes 22, and we can see an increase from 4 o'clock to 5 o'clock, which you'd expect. And day of the week, again, assessing on a day-to-day basis, what is your performance across the days of the week, and finally distribution. So how many journeys were in a given time frame or bracket. So 105 of the journeys were from 11 minutes and then 11 minutes and 59 seconds in journey time. One final thing to add is on the map, you can see that there's specific lines connecting the stops. So here we've got a dotted line, but further down we've got solid lines. The solid lines imply that there is tracks data on BODS. So we have coordinates to fill in the gaps and see what the bus actually is supposed to do on that route. For these dotted lines, we haven't got tracks data on BODS, so it just does a stop-to-stop straight line. So if you want to fill in the data and make it more accurate, then you can add the tracks data on BODS. You can also select a specific stop-to-stop. So I can select these 2 stops, so from Cradlewell to Sandyford. A lot more stops recorded, 1,700 transits recorded, because it's only going through 2 stops. So there's probably more services that go through these 2 stops. 107 of those are missing. Yeah, so we can see the evidence is 248, and that reduces it to 107 missing transits once we use that estimated. So it's helping to fill in those gaps. And you can see there's a lot more services that run through these 2 stops specifically. So hopefully that gives you a good overview of the Analyse Bus Open Data Service. Please do get in contact with us if you have any questions or any feedback on the BODS help desk email. And thank you for listening.